Hey folks, welcome to another episode of Sound Decisions here on Passion for Sound. And in this case, part 3 of the interview with Dan Schmolle from Bottlehead in the United States. I'm recording this video during the COVID pandemic, and I just wanted to take the opportunity to say take care of yourselves, look out for one another, and I hope you're all doing well and you're all safe and sound. Obviously, this is affecting many different industries in all sorts of different ways. It's quite challenging for all of us in many ways. And so one short message that I did want to put out there was that if you're on the fence about maybe buying some audio gear and you're obviously financially comfortable and safe to do so, I'd encourage you to make that decision now to go out there and spend the money. It's going to help to provide job security for people out there that might be doing it tough. I'm not suggesting that anybody should be spending irresponsibly, but if you're thinking about making a purchase and you are in a position where you can safely afford to do so, then please do help to support others around the world who may not be quite as comfortable as you might be. Other than that, I hope you're all taking care of yourselves, isolating at home and enjoying some great music from some great audio equipment. Speaking of great audio equipment, don't forget that the draw for the SMSL SP200 amplifier is coming up very soon. If you haven't yet entered into that draw, it's very simple. Just remember to be a subscriber, so hit that subscribe button and leave a comment down below about something that you might like to see reviewed on this channel in the future. I can't necessarily answer all of those requests with a review, but where possible, I'll reach out and try and get a hold of those products. As always, don't forget that patrons get extra draws. In the recent Ibasso DCO1 and DCO2 draw, one of our patrons actually came up twice in the random number generator as a result of being a patron and getting multiple entries. So don't forget to jump over to Patreon. I'll leave a link below in case you'd like to get some extra entries in the SMSL SP200 draw or any future draws for that matter. I'll be drawing the SP200 giveaway in the very beginning of April, around the 1st or 2nd of April, so watch out for future reviews where I'll announce those winners. Now I should add at this point that if you're not particularly interested in the interview here and you're more hanging out for reviews, I do have lots of reviews coming. I've currently got the Aries amplifier from Sparko's Labs, which is an absolute beast. That's coming up as the very next video. I've also got an interesting IEM project that I want to share with you, and the Shozzy Form 1.4 IEMs have just arrived recently as well. So I've got plenty of reviews coming. If you're hanging out for those, make sure you hit subscribe and ring the bell so you know when those drop. And as I said, the very next video to drop will be back to reviews before part 4 of the interview comes a little bit later on. Now let's get on to talking about this interview. In part 3 here, Dan's going to get into a little bit more of the technical ins and outs of how tubes work, what makes them sound different, how to help prevent microphonics and what microphonics are. It's getting into some really nitty-gritty and, in my opinion, some very interesting content for those of you that are into tubes or just those of you that like to know how stuff works. Specific topics that Dan talks about is what makes one tube sound different to another, either in a particular circuit or just overall. He also talks briefly about things like cryo treatment of tubes and what's going on and does it actually make a difference. As a hint, it does, but it's really interesting to hear Dan talk about exactly what that difference is. And as I already mentioned, he also talks a bit about microphonics in tubes and some of the fun things you can do to actually prevent microphonics if you think that's what's going on. Now, before I get out of the way and let the interview continue, I should just provide a quick explanation of how a tube works, because it'll help to make sense later on when Dan explains some of the things that make tubes sound different and what microphonics are doing inside the tube. So how a tube basically works is you've got a heating element of some description. As Dan mentions later, sometimes it's external to the tube, but in most of the tubes we're working with for headphone and speaker amplifiers, it's going to be a heater within inside the tube. So that is a wire that essentially heats up and causes an electron cloud to be released from what's called the cathode. Now that electron cloud is then attracted towards an oppositely charged piece called the anode. And so what you can imagine is that you've got this cloud of electrons coming out of the cathode and they're being drawn upwards in most cases towards the top of the tube where the anode is sitting. What happens along the way is that there's a grid of wire placed through the center of that path, and that grid is where our signal is passed through. And so the signal is a varying combination of positive and negative charge, and so it influences that electron cloud by either attracting or repelling the electron cloud, and therefore changing how many of those electrons are getting through to the anode at the other side. What that does is it means that essentially the electron cloud is becoming a version, like a photocopy, if you like, of the signal that's on that grid. So that's a really rough explanation. There's some great videos around YouTube that go into detail with illustrations and animations of exactly what's going on. But what you really need to know for this is that the filament in many cases is the thing that's releasing the cloud of electrons. Those electrons are what's going to ultimately form the signal once it gets passed through and kind of filtered and adjusted by the grid, which contains a low-level signal version of our audio. So that then creates a different set of electrons that pass beyond the grid, hit the anode, and that's the signal that comes out into our headphones or speakers. Hopefully that's made a little bit of sense, and it will help you to understand what Dan's talking about shortly in the video. For now though, let me get out of the way and let Dan answer one of the questions that came from one of the patrons. They had a chance to actually pour in some of their own requests and questions for this video. So I'll get out of the way and let Dan answer the question about why some tubes sound better than others in certain systems.
This is actually a question, I'm pretty sure this came from one of the patrons of the channel. They said, why are some tube families preferred over others in certain amp designs? And for example, they said that for a Cavalli tube hybrid amp, which comes from drop or mass drop, the best tube is the 6922 from Electro Harmonics, but for other amps, that might not be the case. So my understanding of that is they're saying that there seems to be this preference, and maybe this goes back to what you were saying before about someone said this family is the best.
That's where I was going to start with my answer.
Okay. That's probably
but certainly there are tubes that become kind of favored for a given circuit. It could probably be different in different situations, but it probably boils down to two things. One is tubes do change their sound as you go through different operating conditions: more current, less voltage; more voltage, less current. Tubes get leaner, fatter, so on and so forth. There might be a tube that hits a sweet spot at the certain operating point of a particular amp design.
Right.
And so that's part of the reason it sounds good. And then I think the other thing is that may have been arrived at, again, because an amp designer has got a certain favorite headphone and they got it to sound really great with that certain headphone.
Yeah.
And consequently, that is the combo that people like. Crack amp, again, it comes up, crack amp. How many guys out there are using something besides Sennheisers with their crack amps? Raise your hands. Not very many.
Yeah.
And
it was not a Sennheiser, it is a Biodynamic T1. So that's
so if you hear the guy says this is the great 12AU7 and this is the great 6080 to use in the crack amp, he probably means with my Sennheisers, most likely.
But then the question still is it the HD 650s or the HD 800s, which are such different sounds that could be influencing which tube's going to be best as well, couldn't it?
Yeah, sure, absolutely. Yeah, and that's the part that makes you crazy, but it's also can be the fun part is rolling tubes until you find the match with your particular headphone. If you want to get rid of that treble peak in the HD 800s, maybe you go this way, and if you want to kind of bring things up a little bit in the 650s, go that way. Something about that, just to digress a little bit, one of the things I've discovered over the years is that the input tube quite often has much more influence on the tonality in particular. And if you give it some thought, there's a pretty obvious reason why. The triode output tubes tend to be very, very linear.
Okay.
The input tubes we try to use linear tubes, but they're not necessarily as linear. Okay. Why does the mainline sound so clean and neutral? Well, that's the only tube in there, and it's a very, very linear tube. Why is the crack something that people love to tube roll? Well, the 6080 and the 12AU7, neither one is considered a particularly linear tube, which means that there can be a lot of different flavors out there in these guys, and you can you can kind of tweak those non-linearities into a particular kind of sound you like.
Yeah, okay, that makes sense.
I thought it'd be a good idea here just to explain what Dan's talking about when it comes to linearity and how that influences the sound of the amp. So the idea is that if you take a tube that is non-linear or less linear, let's say, what's going to be happening is that at certain frequencies it's more or less efficient. So let's say you've got a tube that is a little bit more efficient in the mid-range. What that means is that when the signal's passing through it, the mid-range is going to get a little tiny bit more amplification than the bass and the treble. So that's going to create a more lush, mid-range focused sounding tube. Similarly, you might get one that's more efficient in the top end, and what that could create is a more treble oriented tube that comes across sounding more detailed and a bit more analytical perhaps. Similarly, you might have one that's just less efficient in the mid-range, and that could create your classic V-shaped sound signature where you've got a bit of extra bass, a bit of extra treble, and that would result in a tube that sounds a bit more dynamic and a bit more punchy and exciting overall. So Dan's point here is that by combining different tubes with different levels of linearity, what you're actually doing is having those tubes interact with one another and enhance the same or different parts of the music to create a whole set of different colorations depending on how you mix them together. So hopefully that makes more sense with how Dan's talking about the ability of tube rolling to create such a difference in amplifiers.
So it's all about just playing with combinations in amps that have both sorts of tubes, or in the case of the mainline, I mean, actually in the case of the mainline, it's not really a lot of choices because they're all
no, there's one choice.
Yeah, unless it's a cryo version of it or something.
Yeah, it's cryo or the super low noise, or you know,
Yeah.
or rubbed on the thighs of virgins or whatever, you know. Yeah.
That's right. Yeah.
I won't. Actually, I don't mean to disparage things like cryo treating. Cryo treating does do something. Basically, it speeds up the break-in process, is what it does.
Okay, is that what it is? Right.
Yeah. Yeah.
Okay.
And we learned that years ago. We got it. We actually, it was with transformers, but it's the same effect. It's a metallurgy thing.
Okay.
We got a couple of very small transformers with permalloy cores and you know, super fancy 6/9s, oxygen free, continuous cast, again rubbed over the thighs of virgins kind of wire. and one of them was cryo treated and one of them wasn't.
Yep.
And we set up a test, and you know, had a bunch of guys at an audio meeting, and everybody sat and listened, and we all went, oh yeah, wow, you know, that cryo transformer is a little more natural, more relaxed sounding. It just has a little better flow to it. The other one seems a little bit kind of compressed and uptight, and you know, like something like a, you know, a green transformer sounds. And we kept doing that demo over time. The difference got smaller and smaller because the other one was finally catching up with enough, you know, enough signal going through it and enough heat cycling and so on and so forth. It eventually caught up with the cryoed one. So cryo treating is kind of, in audio terms, is kind of for people who are impatient.
Okay. Yep. Or who think it's special and want to spend more money. In my case, which
yeah.
Because I've got the original pair of tubes that came from Bottlehead with my mainline, and then I did go out and buy on eBay a pair of cryo. I can't remember which brand they are, but I think they're Electro-Harmonics, and the ones that I got with the mainline might have been Sovtek. I don't remember now anyway. But one was cryo, one was not, and yeah, I did notice a subtle difference with the cryo ones. But from what you've just said, I'm just hearing the break-in process.
Yeah, my other concern about these things is that, you know, it could have just been the tubes would have sounded different anyway, even if they weren't cryo.
Yeah.
I mean, how do you know? It's hard to have a large enough sample. Even for us, it's hard to have a large enough sample to be able to determine whether it's actually a consistency of a certain kind of sound in a tube or not. And you know, you read enough on the internet, certain things float to the top, and this is not to say that there aren't any you know, characteristics that aren't consistent in these tubes, but some are and some are not, I think. And it's a little bit of it's a little dicey to make a, you know,
broad statement on that
pontification about it, you know. If it's based on this pair of tubes you bought, you know, it's a little hard to say they're all going to be like
pair
that.
Of tubes in the whole sea, isn't it? Yeah. You spoke about the variations potentially between the sweet spots of the tube and how they're used in the circuit. Is there anything else?
Yeah, well, is this specifically how one tube of a given type sounds differently, like how one 1287 sounds different than another?
Yeah, so I guess I'd relate it to probably the crack's a really good example of people want to roll that main output tube in the crack.
Yeah.
What is going on that's causing the 68 and the 5998 to sound different as you roll them?
Yeah, well, there's a lot of things that are going on there. There's structural stuff. You'll see a lot of talk about how many micas are in a tube. Talk about the shape of the envelope. Those kinds of structural things have to do with something called microphonics or microphony, which is the tube picking up external vibrations and that getting superimposed on the signal that's going through.
Okay.
So sometimes that structural stuff will have an influence on how quiet a tube sounds between notes, those kinds of things. Then there's actual material things about the composition of the parts inside. There's most 6080s you'll see will just have these black plates in them, but there are 6080s out there that actually have graphite plates, and they definitely have a little bit different sound to them. Those were actually really rugged tubes that, well, no 6080 was really ever intended to have audio going through it, but they were intended for really, really rugged applications to hold up really well.
Okay.
And there can be different things that are used on the heaters, the cathodes and the heaters inside. In the case of the 6080, the cathodes, there's different coatings that are used to improve the emission of the electrons, and that varies. Everybody back in the day had their own little secret recipes that they used. And the amount of emission, the size of that density of that electron cloud makes a difference. That can have an influence on how much punch a tube has.
Right.
These big thoriated tubes, like the 845 tubes in that red amp over there, the thoriated filaments were intended specifically to put out this gigantic, really dense cloud of electrons. And because of that, the 845 is a really punchy, dynamic sounding tube, as well as being a very linear tube. So the 6080s, some of them, I think, definitely have a little bit, more oomph in the or just in how it's shaped, even how that cloud is formed around the cathodes and stuff can make a difference in how.
And so that glass, that's the envelope, is the glass around the tube. The shape of those is not just cosmetic, then it actually does make a difference.
Well, I think, I mean, in terms of microphonics, I think it can. Part of that is, I believe that the older style tubes, it had to do with how they were able to throw off the heat that would build up.
Okay.
And I think that as glass technology improved, they were able to make these little more dense, just cylindrical envelopes, as opposed to the old shouldered style like you see on the 6AS7, which is an equivalent for the 60. The 6AS7 is actually the predecessor. The 6080 was the mil spec variant that came later.
Right. Okay.
And are actually more common than the 6AS7.
And that's funny because I think a lot of people are drawn towards the 6AS7 looking a bit more glamorous, and
absolutely,
that changes our perception. It sounds better because it looks better as well.
Right.
I often like that.
That's a huge thing on I've never been too good at that aspect of it, and anybody who looks at my gear knows that. it's not a huge deal for me. I listen with my eyes closed. I don't care what the amp looks like. But I get that. I totally get it. It's a thing that you show off, in your listening room, and you want to have that cool glow, and you want to have cool looking tubes. I'm all for it. So it's cool that there's that option.
It is, yeah. I never realized that was a predecessor. That's really interesting. Speaking of the harmonics, the microphonics, I should say. I'm guessing, therefore, the answer to this is yes. The question is, do things like tube dampers make a difference? I asked that question on the Mainline forum the other day about what's the next upgrade for the mainline if you've changed some capacitors and you're just looking for that next incremental gain. One of the suggestions that came back was is it Herbie's tender feet, I think they're called, which are the soft rubber feet. But while I was on the website, I also noticed they have tube dampers. So I was curious to know, do you believe tube dampers are worthwhile, or is the tube design generally enough to isolate it from the microphonics and vibrations?
Again, it's a case-by-case thing. The short answer is yes. Certain tubes are much less susceptible to microphonics.
Okay.
And as you look at the later tubes that were used in military applications that were ruggedized, stuff that was in airplanes, I had to handle incredible G-forces and still hold up. And so you're talking about little miniature tubes. Generally speaking, those tubes are indirectly heated, meaning they have a separate heater and a cathode, as opposed to a filament that's the thing that is the source of the electron cloud. Those tubes are not as susceptible to microphonics. They can still be, and particularly if you're trying to amplify a really, really low level signal, say from a low output moving coil phono cartridge or from a ribbon microphone or something, then it can still be quite an issue that needs to be addressed. And yeah, damping the tube, as long as you're not overheating the tube, is certainly a good thing to do. If you go to the other extreme of these earlier designs of filamentary triodes, for example, a 300B or a 2A3 or a 45 tube or something like that, they are inherently prone to microphony because they have this long filament wire that's dangling inside and can wiggle around, and that's what creates the ooh that you hear from the tube when you tap on it, the ringing sound. So those tubes definitely can benefit from it. Luckily, in most situations, those tubes are the output tubes, and they're not amplifying very much. The signal's been amplified before it hits them, so they don't add much of that. If you're a really crazy manufacturer and decide to break all the rules, and you decide to make a 300B preamp like we did, then it's a real issue. And we were very careful when we put the B preamp out to say, look, it's a 300B. They're microphonic. You know, get over it. Here's what we've done to try and address that. And I think maybe if I can I do this here? Can I swing around? Maybe if I go move my special custom system here. Oh, it's so far in the background, it's really hard to see, but right there.
So you're talking in the bottom corner?
Right there, to the top of my finger, there's, I don't know if you can see, but there's a B preamp, and sitting on top of the 300Bs are two big orange things, which are actually vinyl coated lead rings.
Okay.
So each tube has about a half a pound of lead on top of it.
Wow. Okay.
And it makes a big difference. The other thing is that those it is up on feet, and it might be. I think that's just on our standard rubber feet, but I have in fact put those on the Herbie's tender feet. I don't pitch products all the time, but those just happen to work really well for that particular application in isolating any not airborne vibration, but vibration from footfalls that might come up through the equipment rack into it.
Yeah,
it's worth isolating that as well. Also in the kit, the tubes come with little silicone O-rings that we actually put right under the tube, sandwiched between the base of the tube and the socket. That helps keep out a little bit of that too. But the big thing is those rings. Now, I've also used Herbie's tube dampers. I don't know if it's a titanium wire or what it is with the little Teflon gizmos on there. And what I found was those were effective for real high frequency ringing. And I think that the ones maybe that he makes for smaller tubes that are more prone to have, because of that really tiny plate structure inside, and grid and cathode and structure inside, they tend to ring at a real high frequency. I think that his dampers may be a little better tuned for that stuff than something like these lead rings would be. But the big old 300Bs, they have a pretty low, it's kind of a mid-band ringing sound that might be, I don't know, 300, 500 hertz, something like that. And you need something a little bit more massive to counter that.
So it just obviously depends on the tube, the size of the tube, the size of the filament.
Right. We've fooled around with a lot of different ways to do it. I think you were mentioning your question that you asked on the Bottlehead forum. I think I suggested in that with the 6045 Pis to try like 3M makes an adhesive copper tape, adhesive copper tape. We used to take some of that and just take a piece and wrap it around the tube and then solder the seam where it overlaps and then tack a piece of wire to it that you could run down and attach to the chassis so that it was effectively a shield, which was the original intention. And then when we rigged that up and started looking at the output of the tube on the scope and tapping the tube with and without that copper tape on there, we found it would made a great tube damper as well for a really small tube like that. So, there's ways you can do it like that. One thing to play around with is also the standard tube shields that are the bayonet style, where there's a spring up inside a tube and that whole thing fits down over a collar that's around the tube socket and you twist it. Those can actually, with the springs in them, we found sometimes they actually amplify the microphonic effect.
Oh, really? Okay.
So if you find that you have a particularly preamps where you find those things, a setup like that and you're having some ringing, you might try, you don't really need to take the shield off all the way. The shield's giving you some benefits in terms of keeping out EMI and RFI, so you'd like to keep it on there. But if you just pull that spring out, usually the shield will still fit on the tube just fine, and that may actually reduce a microphonic effect you might be getting through that. Another solution is to use something called an IERC tube shield, which is a military grade tube shields that were, I think they first came out probably in the 50s or 60s, and they're pretty easy to spot. They're black, and inside, instead of having a spring, they have a little corrugated piece of aluminum that's shoved up inside there, and that actually fits around the tube. Does a nice job of damping microphony, and the other thing is it pretty consistently lowers the tube envelope temperature about 15 degrees.
It's working like a heat sink as well.
Yeah, which is a nice thing to help keep your tube lasting a little longer.
Yep. Interesting. Okay, that'll give some food for thought for tinkerers like me.
Yeah, there's a lot of fun things to play with. Yeah. With the microphonics thing, you kind of want to start by determining what the source is that's causing it. We the one that cracks us up is we get these guys who come on the Bottlehead forum and say, every time I tap on my tube, it rings. What should I do? And we tell them, stop tapping on the damn tube. Simple. But there are kind of two potential sources, and one's easier to deal with than the other. One is airborne, and that is when your speaker's playing so loud that it's actually vibrating the tube. And usually distance is your best friend on that. Quite often we'll find a guy says, yeah, I'm having problems with microphonics. And we'll say, well, where's your amp? Well, I set it right on top of my left speaker or my subwoofer. Okay, just move it. That usually solves the problem. The other one is again, like I was saying, sort of ground-borne. It's footfalls and things. And the best way to deal with that is usually get something under the entire piece of gear. The simple way I've done, just kind of field expedient when we've had an issue in a studio or something, is just get some bubble wrap and fold it up. Okay. Set it underneath the amp and set the amp on that. That does a pretty good job of isolation from any vibration that might be coming up through.
It's going to take a bit of wobbling out of it, yeah?
Yeah. I mean, the amp itself can actually wobble more, but it's sort of countering any vibration below. It doesn't get transmitted up through. Yeah, it isolates it. Yeah. So that's a really ugly field expedient, but it does work, and maybe it's a starting point sometimes. If you can't determine what's causing the ringing you might be hearing in a system, that's a way to deal with it.
Good. Yeah, it's a good test before you go down a more permanent solution, perhaps. Isn't it?
Right.
Yeah. Fantastic.
That's it for part 3 of the interview with Dan Schmolle from Bottlehead. Part 4 will be coming soon after a short interlude where I'll drop at least 1, maybe 2 review videos. So if you're hanging out for those, they're on the way. And do make sure you hit subscribe and ring the bell to find out about when those drop, both the reviews and part 4 of this video series. As always, if you've enjoyed the video, do hit the like button, it really helps. And I'll look forward to seeing you here next time on Passion for Sound.